I'm Seán Vicary, and I work with Steve Knight, and together we work together as Tinder Farm. And at the moment, we're looking at creating a virtual 3D representation of a bear mandible that was found at White Sands, and we think it's about 6,000 years old. So that involves, the process is known as photogrammetry, and it's something we've not done it before, so we're kind of really excited about going on a little creative journey to see how this process works. We both work and we come together to work on projects that are kind of that we'll enjoy working on. Both Steve and I have different hats that we wear. I work as an artist, Steve works as a programmer, and I'm sure he'll tell you. But we work together on things that really fire us up.
The first thing that we did was go straight in there and do some practical tests with what we had to hand. In this case, it was our phones, our mobile phones, and some objects that we had in the studio. So there's a bunch of kind of photogrammetry apps that you can get for your mobile phones, which are really quite good for what they are. And we thought we'd just start with those because they were free and available, and we could kind of just get a feel for this overall process that we were going to explore. So, and they were quite useful in identifying problems that we would have when we stepped up the workflow. So the first thing that we noticed straight away was that these apps were much better for kind of using on larger objects than smaller ones. We also noticed that the way that we'd passed around the objects with the camera had generated lots of noisy backgrounds, and that had interfered with the model that we wanted to focus on. So the backgrounds almost welded themselves into the model. So that would have meant a lot of kind of post-production cleanup to separate the model that we wanted from the backgrounds. So although these were kind of quick, fast, cheap tests, we did actually start to narrow down the workflow of the software and the hardware that we were going to use. Rather than continue with our dune models, we decided that we'd try and find an object that more closely matched the bear mandible that we'd be using for the final project. And luckily, in my arts practice, I work a lot with found objects, and certainly a lot of kind of natural objects, including animal bones and skulls, which I use to build constructions that I animate using stop motion. So I have this kind of resource of lots of kind of boxes away and shelves in the attic of these kind of objects. So I went and had a rummage through those, and I found a small jaw, which I think comes from a fox, a small, just single jawbone. And we thought that this would give us the closest kind of approximation to texture and the reflective characteristics of the bear mandible. And so that if we use this small little jawbone in tests, then we could preempt and troubleshoot any problems before they arose on the day of shooting when we go and film the actual bear mandible.
So I'm Steve Knight. I work with Seán Vicary as Tinder Farm. I'm a software developer and tinkerer with hardware and Raspberry Pis and 3D printing and all that sort of stuff. So we've been doing this project to photogrammetry and scan the bear mandible. It's been an interesting process, and I think photogrammetry is a really flexible solution, so you can use it to scan kind of large areas, drone footage, buildings, rooms, things like that, but you can also use it for very kind of small objects as well. We had identified early on that the highest possible quality was needed in capture, so raw files from our Canon cameras were the best option. In terms of the photogrammetry processing, Mae'r was chosen because it had really good reviews amongst the photogrammetry community, and also importantly, it's got a fairly accessible learning curve, and it's open source, so it's free to use. Where possible, we were really keen to use open source and free software, keeping the workflow as DIY and low cost as possible, so that process would be available to everyone. We decided to build ourselves a lightbox to give us a controlled environment for the photography. We made this from some simple sheets of white foam board, some 3D printed corner brackets. On the top sheet, we placed several rows of white 12-volt LEDs. To get a smooth, infinite background, we used a roll of white paper designed for wide format printing and just cut sections off as we needed. This smooth background, combined with the diffuse white LED lighting, gave us the perfect conditions for the photography.
Using a light box really limits the camera movement around the object. You can no longer kind of get around behind it and shoot 360 degrees around the object. So we wanted to take that limitation and turn it to our advantage. And we thought a really good way of doing that was placing a turntable inside the light box. This has a kind of number of advantages. It avoids any messy or difficult background extraction because you've got the wonderfully clean interior of the light box. If you can shoot everything really well, that saves so much time in post-production. And we were constantly evaluating our process to kind of minimize that post-production time. We didn't want to do lots of lengthy kind of digital cleanup on the models. We wanted to shoot everything as in the best quality that we possibly could that worked seamlessly with our post-production process. Another advantage, of course, of having the object on a turntable is that it keeps handling to a minimum. And with something like a prehistoric bear mandible, you don't want to keep picking it up and changing position all the time. When we sat down to evaluate the tests, we thought that this new workflow with the light box and the turntable worked so well that it really gave us confidence to go ahead and schedule a shoot of the bear mandible down in South Pembrokeshire. Actually getting hands-on with the mandible was wonderful. I'm currently making an animation for an arts project that looks at the submerged forest at White Sands, and I'll be using the 3D models we make within that. But there's something really magical about holding that jawbone in my hand. It really physically resonates, and it's incredibly evocative of place and time, almost kind of transporting you immediately back through thousands of years to that kind of forest on the coast. And I'm really interested in how we might be able to communicate those kind of feelings digitally, or whether it's possible to do that. One of the first steps was to mount the mandible onto the turntable. And I'm lucky in that I'm often animating very fragile objects as part of my arts practice. So I was able to bring some of those skills to this task. So I wired up the mandible with very soft, malleable wire that I normally use for building stop-motion armatures. And that let us adjust the mandible's position and angle on the stand very accurately, but very easily with this animation wire.
So we had a fox's jawbone, and we kind of had done some tests on that. But that was very light and quite reflective. And smaller than the bear mandible. So when we saw the bear mandible, I picked it up and loads of sand fell out of it. So it's literally come kind of raw and ready from when it was picked up on the beach. And it's very dirty. Its patina is very dark, so it reflects the light in a different way. So we've done a number of passes kind of this morning that, and we're having problems with the computer, takes a whole series of photographs around the object. And then it tries to map where those are taken from in three-dimensional space to build a mesh. And if it can't quite see the object, the detail in the object because the kind of surface is too dark, it's looking for things to track, and looking for kind of things that it can follow as the camera moves around it. Then it loses it. So we kind of tested on the wrong kind of things. So we had to go on a learning curve today to kind of see how we could fix that problem. And we think we have, but my colleague Steve will tell you about that.
I had some interesting experiments because photogrammetry likes a varied and different texture to kind of locate itself where it is on the object for each of the camera shots. And parts of the bear mandible didn't have a lot of texture, so we've had to kind of add markers in, other things around it, so to help the software kind of locate itself, basically.
The software creates a virtual wire mesh of the object and wraps that in a texture map created from the photographs. It's really important to set up the software to generate the highest quality texture map you can for the best end results. The photogrammetry software will generate a digital model, but it doesn't have the tools to edit it any further. So we need to take that file into another 3D modeling program to clean it up. And we chose Blender to do this, which is a professional 3D modeling and render program that again is also free and open source.
One of the byproducts of the process is that Meshroom doesn't distinguish between the target object and any supports, markers, and bits of stray background that it may have captured. So in order to deal with this, we have to go into Blender and manually edit out those unwanted features. We had to pay careful attention to the removal of the wire supports from the final object. We found that editing the model with flat shading, as opposed to the texture map, let us see and smooth out those unwanted bumps much more easily. Although we had deleted all the unwanted modelling, the drawer is still using a large texture map that refers to the original photographs. So we needed to go in and edit this, removing all the unwanted details, otherwise we could be left with a much larger file than we needed, which would cause problems when we embedded it on a website. We had to be careful that we preserve the link between the model and its texture, so in Blender we unwrapped the mandible into a blank texture map. We then extracted just the texture we needed from the original map and fixed it into this blank template, preserving the alignment and texture detail so that when it's rewrapped around the mandible, it fits perfectly in place. The texture map still contained traces of the wires we used to support the mandible, so we needed to remove these and replace them with the correct texture. This involved working directly onto the 3D model in Blender using a photographic cloning brush.
Once the model is finished, we can export it from Blender in a variety of formats suitable for different uses. For example, as an STL file for 3D printing, or an OBJ file for using on the web or in other 3D applications. In order to present the object as an interactive model on a website, we wrote a small embeddable application based around the 3.js library. It was at this stage we brought the two separate mandible models together to recreate the jaw. We used reference photographs to give us the correct angle between the mandibles and created an option for the user to view them separately or together at the touch of a button.